Hello everyone, welcome to Lab 2 experiment, which is a strength of material lab. Today we'll perform experiment number 16, the investigation of the mode of deformation in a thin-walled cylinder submitted to internal pressure. So basically our objective is to study the hoof stresses in the wall of a vessel depending on the distance from its ends submitted to internal pressure. So this is our cylinder full of air, for example, with some specific pressure. The radius of the cylinder is known, R capital, and we want to study the effect of this pressure in terms of stresses on the surface of the cylinder. And we all know that the hoof stress formula, finally we'll get to the value of hoof stress. Yes, so the hoof stress in the theta direction will be the pressure, so P1 and P atmospheric. The P atmospheric is the transformation unit. It is 1 multiplied by 10 to the power 5, which is Pascal, and then we multiply it by P1. P1 is the value that we are measuring through our device, and then multiplied by d over 2, which is radius of the cylinder, and h is the h is the thickness of the cylinder. So we can calculate some values. This is for theoretical calculations. For some positions we can find the values of the stresses, and we can do also the measurements from the experimental data obtained. We can find the 6 elements of stresses available into our specimen. If I go back to the specimen itself, this is our cylinder. We'll be able to plug the compressor in here, and we fill the cylinder with compressed air. We can control the value of pressure because we need a fixed pressure, and we have sensor number 1, 2, 3, 4, 5, and 6. Some of them will measure the axial, which is in x-axis direction, and some of them will measure in theta axis or theta direction. So let us fix our experiment and try to perform that experiment. Good. So if we want to assemble the experiment, step number 1, install the specimen number 10 for loading of pipe into the mounting hole 8. So this is the specimen number 10. This is a cylinder. We have multiple sensors, 1, 2, 3, 4, and basically what we are doing, we will fill this cylinder with air, and at the end we will measure the stresses, hoof stresses around the surface of the cylinder. So this is specimen number 10 in hole number 8. So 1, 2, 3, 4, 5, 6, 7, and 8. We will fix this here. 10mm bolt. Good, we are done. So step number 2, we need to position the compressor 19 and its power supply. So this is the compressor. Basically, we need to connect the wiring, this tube from the compressor to the cylinder. So this is the connector. Good. And this is the pressure gauge if you want to measure the pressure inside the cylinder, and this is the power supply. So we connect the compressor into the power. This is positive, and this is, let me just put it like this way, yes, negative and positive. Good. Last step, attach the pipe, the air pipe, we already did that. Attach the connector on the specimen 10 to the matching connector on the system. So this is the wire coming from the computer, and this is the piece for that. So by now you'll be able to transfer the signals out of these sensors into the computer. Connect the compressor and everything is ready. Let's now do our experiment. So for conducting the experiment, step number 1, assemble the test machine as described above. We already did that. We need to run the strength of material lab software. So if you go to desktop, this is strength of material software, double click, it's already open in here. Good. So this is experiment number 16, investigation of the mode of deformation in a thin walled cylinder submitted to internal pressure. So click experiment number 16, double click. Okay, this is our experiment. So as usual, we have the specimen parameters. So this is the coefficient of sensors, diameter, modulus of elasticity of the material, Poisson ratio, the thickness of the wall, and all other specifications. Table of increments. So in this table we will see the readings will only apply two pressures, initial pressure and another high pressure. Specimen and diagrams. This is for the results of the sensors from 1, 2, 3, 4, 5 and 6. So if I go back to the manual, so run, we did that, open the lab, it's already given, enter the specimen data, we didn't change anything. So click start. So we should click start on the software so that we measure the initial pressure. So start, you will see that the initial pressure is almost 0, which is 0.2. Now going back to the manual, we need to power up the compressor using the switch on its side and apply a new pressure of 3 kg per centimeter squares. So we can power the compressor on and off based on the measurement available to us or on the pressure measurement device available in the hardware. So I will run the compressor and at the same time I'll be measuring the pressure on the device. So this is to make sure that I have zero pressure. Let's start again. Start. Good. So we have zero pressure now, and let me add the pressure up to 3. So almost we added the pressure to 3, and now we can measure. So this is the two pressures, one is 0, the initial one, and the other one is 3, and in here we can measure all experimental values from the sensors and the theoretical calculations, and this is the deviation values between theoretical and experimentals, and these are the diagrams showing the increase in the pressures in sensors from 1 to 6. Good. If I want to save, go to menu and save. Okay, the Excel file should be generated in my computer. Disk C, strength of material, Excel. Yes, this is. So experiment number 16. Yes, right. These are the values for all. Let me reduce this. And we have tables for calculations for experimental and theoretical, and table for comparison between the results. Yes, that's it. So thank you very much.